Alrighty, folks. Today we are going to begin our discussion of forces and motion by beginning to talk about speed and velocity. Alrighty. So, our learning target for today is I know how to calculate speed or velocity. And I want you to go ahead and set up your notes for today. Our topic is speed and velocity. Our essential question is how do you determine speed or velocity? All right, let's start off with this, the long and winding road. I want you to think about traveling on roads or paths. And sometimes you travel on a straight path that just goes from one point to another. Other times you have a road that looks like this, that is windy. Maybe it's along a cliffside. Or if you've ever been hiking, maybe you're familiar with roads, those paths that go up and go back and forth, back and forth. They're called switchbacks. So it's not a direct line up to the top of the mountain, but instead you're going back and forth a lot. So there are a bunch of different ways that you can reach your destination, and it just kind of depends on what the path looks like. So when we are talking about going from point A to point B, we need to consider two different ways of measuring it. The first is going to be the distance. So this is the length of a path between 2 points. So the distance is the journey that you actually take. So think about that windy road, or think about the switchback example. The distance is going to be every single time, or every meter that you go on the path. Whether you're taking corners, you're going in loops and all those different things, all of that counts towards your distance. However, displacement is the most direct straight line distance an object travels between points. So that is, some people might call it as the crow flies from point A to point B. That is displacement. So I just think of it as displacement is the shortest path between A and B. So sometimes we're going to use distance, sometimes we're going to use displacement, but we need to be familiar with distance and displacement. And you can see here, just so you're familiar, we're not going to use this too much, but distance is a scalar quantity, whereas displacement is a vector quantity, and that's something that will come into play later, but it's not something we need to worry about too much right now. So, what question does the previous slide answer? All right, so like we have distance and displacement, we also have a difference between speed and velocity. So, speed is the distance an object moves over a period of time. So, for example, in a car, if you're familiar with speed in a car, it's usually measured in miles per hour. So 60 miles per hour, that is a speed. However, velocity, this is the speed and direction an object is moving. So 60 miles per hour north, that would be a velocity. So I have a map here of a route that I drive quite often, which is the route from Minneapolis to Kansas City and then Kansas City back to Minneapolis. My family lives down in Kansas City. So if I were to tell you that I'm in Des Moines, Iowa, which is right here, kind of a little bit beyond the halfway point, and I was telling you, hey, I'm in Des Moines, Iowa, and I'm traveling 60 miles per hour. Okay, that's nice to know, but what does that really tell you? It tells you my speed, but it doesn't tell you the direction that I'm going. So if I told you I'm going 60 miles per hour in Des Moines, I could be going 60 miles an hour towards Iowa City. I could be going 60 miles an hour towards Omaha. I could be going 60 miles an hour towards Kansas City, or I could be going 60 miles per hour towards Minneapolis. But it doesn't necessarily tell you exactly where I'm going. Whereas if I told you I'm in Des Moines and I'm going 60 miles per hour north, you would then know, hey, he's heading towards Minneapolis. So that's where velocity is going to be different, because velocity takes into account that direction. And that also makes velocity a vector. Now, here's the thing. Physics, you can add a bunch of different layers onto how you are doing physics. Because we are doing the just kind of foundational work of physics, we are measuring velocity in one dimension. Okay, so we're not necessarily, or basically, we're taught just imagining that everything is going the same direction. And so, because we are measuring velocity in one dimension to start off our studies, that means that speed and velocity are the same thing because in our examples, there's really going to be only one direction that an object can be going. So that's just something to consider. Um, just for the sake of that, we are going to use the words speed and velocity interchangeably throughout this unit. But do know we are doing that for a specific reason, and that is because we are measuring things in one dimension, which makes speed and velocity the same thing. What question does the previous slide answer? All right. So we've been talking a little bit about vectors. Go ahead and pause my lecture video, head over to the Nearpod, and you'll see a nice little clip from the movie Despicable Me that kind of talks a little bit about vectors. All righty, folks. Hope you enjoyed that. All right. So next up, average speed. So this is what we're ultimately coming down to because what we're going to be calculating is the average speed. And you calculate average speed by doing the distance an object travels over the time it travels. Whereas if you were figuring out velocity, you would do the displacement an object has over the time. But remember, because we're only in one direction, one dimension, distance and displacement are going to be the same thing because everything travels in the same direction. So distance divided by time. And so in formulas, I would give you two of the three following. I would give you a distance, a time, or a speed. You'd get two of the three and then solve for the third. Right over here, I have another formula triangle like we've learned about with distance on top and then velocity and time on the bottom. So you can use the formula triangle to solve for your speed equations or velocity equations. So let's go ahead and use an example. So if you go to page 10 of your packet, question number 1 is a bicyclist travels 60 kilometers in 3.5 hours. What is the cyclist's average speed? And question 4, how long would it take you to swim across a lake that is 900 meters across if you swim at 1.5 meters per second? So I'm going to go ahead and ask you to pause, try to solve these two problems, and then come back and I'll walk you through how to solve them. All right, so let's go ahead and look at problem number 1. A bicyclist travels 60 kilometers in 3.5 hours. What is the cyclist's average speed? Well, we are solving for speed or velocity, so we're going to cover up the v right here in our formula triangle, which leaves distance and time. Distance is over time, so we divide distance by time. And we will have velocity equals distance divided by time. Our distance is 60 kilometers. Our time is 3.5 hours. 60 divided by 3.5 is 17.1. And then your unit, you need to make sure that you combine the two, kilometers per hour, km over hr, kilometers per hour. Remember that when you answer these questions, you'll get you'll get 1 point for the number, and then you'll get a point for the unit. So make sure that you are getting that unit correct. All right, problem number 4. How long would it take you to swim across a lake that is 900 meters across if you swim at 1.5 meters per second? All right, so we have we are solving for time. How long would it take? So we're going to cover up the t in our formula triangle, and that leaves us with distance and velocity. So we're going to do d over v. T equals d over v. The time is 900 meters, or the distance, sorry, is 900 meters. The time is 1.5 meters per second. And we're going to go ahead and do the math. 900 divided by 1.5 is 600. When you divide meters by meters per second, the time unit that you are going to get is going to be seconds. And so 600 seconds would be our answer. And I would recommend, just for the sake of simplicity, use whatever unit you end up with and don't try to convert this into minutes or something. That will give you the best answer on Schoology. So there you go. That is how we calculate average speed. What question do the previous slides answer? All right, so instantaneous speed. Now, average speed is useful for knowing how long it's going to take to get somewhere. However, instantaneous speed is how fast you are going at a particular moment. So think back to that bicycling example that we used where the guy was going, I think it was like 17 kilometers an hour. So that cyclist travel, or if a cyclist travels 60 kilometers in 1.5 hours or whatever it is, the question is the cyclist traveling at a constant speed the entire time, or did the cyclist stop at some point and take a water break? Did the cyclist blow a tire? Did the cyclist slow down when going up a hill? The fact of the matter is that cyclist probably was not going the exact same speed the entire time. In reality, that cyclist speed fluctuated up and down depending on what was going on. If we were to try to track that cyclist in the moment, we would find out that cyclist's instantaneous speed. And so you can think about this as like the speedometer on your car or on your parents' car. That tells you the instantaneous speed. What is the speed in the moment? Obviously, you're not traveling 60 miles per hour the entire time you're in the car. You're going to reach stoplights. You're going to go in different speeds areas. And so while your instantaneous speed may be 60 miles per hour at one point, your average speed is going to be lower than your highest instantaneous speed. So uh, you can kind of think about that. And then, I always think it's kind of interesting. What is the fastest instantaneous speed that you have ever traveled? Because, walking at an instantaneous speed, that's one thing, but then have you gone flying? You've been in an airplane, that's going to be a much higher instantaneous speed. So it is kind of an interesting thing to reflect on, instantaneous speed. All right, so to kind of finish up here talking about average speed versus instantaneous speed, let's go ahead and apply physics to a classic fairy tale, The Tortoise and the Hare. To give you the very quick version of it, a tortoise and a hare are having a race, and they start off, and the hare sprints ahead of the tortoise and gets a huge lead on the tortoise. Well, when the hare is very close to the finish line, the hare is just like, oh man, I've got this. So I'm just going to kind of sit back and relax, eat, and maybe take a nap. So the hare falls asleep. The tortoise very slowly and steadily continues along the track and ends up going and finishing the race before the hare. Um, and so, even though the tortoise is quote unquote slower than the hare, well, the tortoise's instantaneous speed would be much slower than the hare's top instantaneous speed. However, because the hare stopped and took a break, the average speed of the hare decreased to be less than the average speed of the tortoise. And so that kind of once again gives you a difference between the average and instantaneous speeds. All right, so what question do the previous slides answer? All right, folks, go ahead and pause this video and go through and take the quiz to see how you do, and then come back and we'll discuss. All right, so Manu drives from Stillwater, Minnesota to Fargo, North Dakota, and then back to Stillwater, Minnesota. Clarice drives from Stillwater, Minnesota to St. Paul, Minnesota. Who traveled a greater distance? Well, even though Clarice is farther away from her starting point by going to St. Paul, and Manu is in the same starting point as his end point is the same starting point, the same as his starting point. Manu did travel from Stillwater to Fargo and then back. So his distance, the actual journey that he went on, was much greater than Clarice's. And so Manu is the one who has the greater distance. You need to go to the restroom. You start at the science bathrooms, but they are locked. So you walk upstairs and the bathrooms are locked. So you walk over to the bathrooms by the English classrooms and then they are locked. You walk back to the same science bathrooms you started at and they are now unlocked, so you can use the restroom. What was your total displacement in this journey? Well, because your starting point is the same as your ending point, you actually have 0 meters of displacement. By the way, this is a reference to an issue that we had in the high school a couple of years ago where the bathrooms were getting locked and it was very hard to find a bathroom that was open to use. So a little bit of context there. You run 50 meters in 10 seconds. What is your average speed? 50 meters divided by 10 seconds gives you 5 meters per second. The speedometer on your car tells you your instantaneous speed. So if you answered those four questions like that, you should have gotten 100%. Alrighty, folks, I want you to go ahead and rate yourself on a scale of 1 to 5. How well do you understand distance, displacement, speed, and velocity? Alrighty, folks. So, now that you are done with this, I would like you to go ahead and head over to the Schoology folder. In there, you will find some practice that is also in your packet, along with keys and tutorials. So there is plenty of material for you to work on. So make sure that you are ready for tomorrow's quiz. Have a great day.